Hi, everybody. This is Miss McClellan, here to go over your questions from Homework 4.3. I've grouped the questions that you emailed based on similarities. First two questions: how do you find the probability on a density curve, and how do you find the probability of a density curve? What we actually find is the probability under sections, which I should call intervals, of a density curve. And we've done this a lot already. The most familiar density curve we have to talk about is the normal curve. So suppose I have a normally distributed distribution with a mean of, I don't know, how about 164, and a standard deviation of 2.4. Well, if I wanted to find the probability that a certain value in my distribution chosen at random was above 172. So if I had my mean at 164, 172 would be somewhere above around here. I would be wanting to find the proportion of the area under this section of the curve. And what I would do is I'd find this area right here. I would use normal CDF with a lower bound of 172, an upper bound of some very, very big number. I'll do 99999, some huge number, with a mean of 164 and a standard deviation of 2.4. I'm going to go ahead and do that. So I want to do normal CDF. So I'm going to go second, choose my distributions, normal CDF, enter, lower bound. I believe the problem that I just did was 172 with an upper of some very big number, mean of 164, and standard deviation of 2.4. Let's double check those values. 164, 178. Okay, good. I'm going to press enter. And I get a very small probability, 4.2 times 10 to the negative 4. 2? More like 3. 4.3 times 10 to the negative 4. This is very unlikely, which, makes sense because 164 plus 1 standard deviation would only get me to 166. Then I'd be around 168. Then I'd be around 170. I'm more than 3 standard deviations away from the mean. That probability should be very small. So all of this was just to say we have found probabilities under density curves already. The only difference is now we have more than one density curve to deal with. And truthfully, we used to call it percent of population under the curve. And now we're talking about proportion because probability is written as a proportion between 0 and 1. So on to the problem that was actually in your homework. How do we find the probabilities for a density curve? And again, we should say under a triangle. Well, in your homework, you had this problem. It looked like this. You had a triangle. Height was 1. Length was 2. And we had probability on this axis and x on this axis. And we were asked to find a number of things. First of all, recall that the area of a triangle is 1/2 base times height. We're going to use that. The area under this whole triangle is 1, which is why this gets to be called a density curve. And to find probabilities under this curve, we're just finding the probabilities in certain sections of the triangle. So the first problem was the probability that x is greater than 1. Well, that equals, let's see, here's 1. The height at 1 should be 1/2 because it's a midpoint, and here is 1. So the probability that x is greater than 1 is the area, and I'll do it in, since I have to do 3 problems, I'll use color, in this little triangle. And that's 1/2 times the base, which is 1, times the height, which is 1/2. And it ends up equaling 0.25. The probability that x is less than 1.5. And I'll do that in another color. How about blue? So here's 1.5. And that's the midpoint of the midpoint. So this should be 1/4. And I want everything over here. Now, there's a couple of ways you can do this. You can find the probability of this blue trapezoid, but I'm going to do complement. I'm going to say that this is going to equal 1 minus the probability that x is greater than 1.5, because it's much easier for me to find the area of this tiny little triangle. So this is equal to 1 minus area of this little triangle here, 1/2. The base is going to be 0.5, so 1/2. And the height is 1/4. So that's 1 minus 1/16, which, if you do that, equals 0.9375. Okay, and the last one, I'll color in green. I want between x is 0.5 and x is 1.5. So this section right here, oopsie. This section right here. Gross. So if you know how to find the area of a trapezoid, this is easy, but I don't want to rely on that because it's something that we would need our memory for. So I'm going to find this in parts. The probability that x is greater than or equal to 0.5 and less than or equal to 1.5 is going to be the area of this trapezoid. And I'm going to do that as triangles. So, and rectangles. So first I'll do this little rectangle here. That's height of 1. Sorry, length of 1 and height of 1/4. That's this section, that area, plus that triangle, 1/2, base of 1, height of 1/2. So this is going to equal 2/8 in total. But let me draw that triangle piece to make it more clear. There we go. So this is 1/4 plus 1/4, and that ends up equaling 0.5. All right. Okay, next question. How do you manage an absolute value inside of a probability question? I'm not totally sure what you're referring to. I think that you might be asking a question. So for this one, I'm not, again, sorry, totally sure what, but I'll give it a shot. if you're asking, how do I handle the probability that, for example, the absolute value of x is greater than 1, well, then I have to think about what absolute value equals. And here is 0. Hold on. An absolute value is about distance. So distance from, distance from 0. It could be positive or it could be negative. Either way, that absolute value of either of these sides would be 1. That's this. So this is the same as the probability that -1 is less than x is less than 1. So you'd be finding the probability of that interval. You could be referring to that. I know probabilities like that turned up in your Khan Academy problems, but I think you could also be referring to the homework problem, the challenge problem, where you had the probability of x is equal to 6 minus x minus 7, all divided by 36. And for this one, you're given a table of the distribution, and you would be just plugging in values. So when x is 2, you plug 2 in. That becomes 6 minus the absolute value of 2 minus 7, which is inside the absolute value part would be -5 all over 36. And that gets you 6 minus 5 over 36, so 1 over 36, etc. This is the top example I made is a common question. The bottom example is a sort of unique question. This one, if you were asking about this, is more useful because it generalizes more often. Anyway, number 5, the probabilities of x always have to be yes. Do the probabilities of x always have to be represented by a number between 0 and 1? Yes, by definition. Now, you might have a table where you had counts. These would be called counts. Or frequencies. And you use them to find probabilities. So I really like that you asked about out of 44 options because that makes it easy for me to explain this. For example, the probability that x is 0, 1 would equal 1 out of 44 options, assuming that these are all independent. Okay, next, statistics and probability distributions. Your table mates were wondering about the process of combining normal random variables. Well, when you combine normal random variables, which is not the same as performing linear transformations on random variables, a couple of things happen. In particular, it's important to keep in mind that, for example, y equals x plus x. Let's say we want to consider y equals x plus x, where x is representing the distribution 1, 2, 3 with probabilities 0.1, 0.6, and 0.3. Well, I could model this combination 1, 2, 3, 1 with an area model, which we don't really have to do in this class per se, but I think it helps for clarity. So 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, 1 plus 2 is 3, 2 plus 2 is 4, 3 plus 2 is 5, 3 plus 1 is 4, 2 plus 3 is 5, 3 plus 3 is 6. And the probabilities in here would be 1/9, 1/9, assuming these are all, oh, sorry, not 1/9, ha ha ha, because these aren't even. This is 0.1. Gross. Students, let's make these even so that the example is easy to do. 1/3, 1/3, 1/3. Then these can all be 1/9. Well, here, the distribution of y and the probability of y would be 2, 3, 4, 5, 6 for all of the possible outcomes. And the probabilities would be 1/9 for 2, 2/9 for 3, 3/9 for 4, 2/9 for 5, and 1/9 for 6. I guess all I really want you to see is that y equals x plus x is different than z equals 2x, which would just be the distribution 2, 4, 6, and the probabilities wouldn't be changed. I think what makes combining normal random variables hard is understanding that x plus x is not the same as 2x. And it has to do with the fact that the probabilities of independent random variables are multiplicative. So I encourage you to go back and look at those notes and ask more questions about this. For now, what I want you to take from this is that combining random variables is not the same as doing linear transformations. All right, we continue. How to draw a probability histogram. This is totally not that bad. So you go list one, or you don't even have to. Like, let's do a probability histogram for this distribution. Y, 2, 3, 4, 5, 6, from above. 1/9, 2/9, 3, sorry, should have been 9/9, 2/9, and 1/9. Histograms, the bars touch. We have these outcomes: 2, 3, 4, 5, 6. 2 is 1/9. Oopsie. 3 is 2/9. 4 is 3/9. 5 is 2/9, and 6 is 1/9. Done. You can also make your calculator do it with lists. List 1, y, list 2, probability of y, and then from there you do stat plot, turn on, and then choose histogram option and adjust your window. But honestly, unless you have a random variable with a lot of outcomes, I think it's easier to just draw it by hand. How do you do a probability distribution with percentages? Put the percentages as decimals. And then you're done. Okay, next question. Applying statistical concepts to specific problems. Specifically, a problem asked how to prepare inventory for 5 days. Would I use the mean for this or the maximum for this calculation? You would use the mean. Also, thank you for asking this question because I agree that it lacked clarity, and I don't think it was that you didn't understand. I think it was that the problem was a little bit ambiguous. So for next year, I will make the problem more clear. Honestly, if you use the maximum, I think you're even a little bit more correct. The only reason I'm telling you that you should use the mean is because I know that uh, more often than not, you're interested in expected value, which is another word for mean. Number two, asking a question about homework problem number 7. Let's see. Number 7 said, if I can just remember. Oh, the insurance company problem. I've got you. Um, I think let's have this question asked again. Um, but I'll talk through the problem a little bit, assuming you've already seen the key. So we have age at death and probability of X. And X had ages. We've got 25, 26, 27, 28, 29, and then 30 plus. I'm going to fill in these probabilities 0.00039, 0.00044, 0.00051, 0.00057, 0.00060, and then this is just the complement. So all those things added together subtracted for 1, and it's 0.99749. Complement of everything else. And that was this right here was the answer to part A. Okay, then part B says, assume that there's an insurance policy, it pays $100,000 if this person dies within the next 5 years, and the cost is $175 per year. So you're making another table, and we're going to let y equal the probability that we're going to let y be the random variable of how much money gets spent. So first of all, if the person dies next year, they've spent $175 and the payout is $100,000. So the insurance company is out 99825, and the probability of that is the same as the probability above. Okay, next, the person dies after 2 years. Now they've spent $175 twice. The payout is 99650. Okay. Etc. So every year that the person lives, they give the insurance company $175. So the amount of money that the insurance company pays out in effect is decreased. So this is negative 99475, negative 99300, negative 99125. But if they don't die within the next 5 years and the policy expires, the insurance company will have made a total of 875 and paid nothing. So that's this distribution. And then you can find the expected value of how much money the insurance company will end up with, and that is the expected value of the distribution of y. So sorry for writing x, let me write y. And that equals 623.22. Okay. Understanding mean and standard deviation. How do you find mean cash intake with the table in part B? See above. When you interpret the standard deviation of random variable, is there a script? Yes, there is. Let me write it. Just 1 second. I want to make sure I say the right thing. Almost done. Over the long run, we expect the typical variation from the expected value to be blank and then plus context. And interpreting and calculating expected values, this is just interpreting, so that's kind of not correct. Let's give a script response for that one. In the long run, we would expect a value of blank and then plus context. Okay. That's all of the questions. I hope you have a great day, and I'll see you next time. Bye.